I'm gonna start from complete scratch because now I want to review each pillar of object-oriented programming. Job application, lecture. And this is actually lecture 14 and 15. Well, actually, this is lecture 15. All right, so we're starting from scratch. So for this example, what I'm going to do is create a generic superclass called electronic device, or actually, let me just call it device. From device, we'll have a couple characteristics. We'll have the manufacturer. We'll have the height, length, and depth. We'll have the weight. All right, those are just generic things with any device, typically. So let's create that new Java class device. All right. This device, we have double height, double length, and double depth, right? Height, length, or height and width, height, width, and depth. So how big it is in a 3D space, three-dimensional space. It also has a double weight. Right? Those are all the characteristics of a device. Okay. Now we must provide a constructor, public. I'm going to provide a default constructor, so no parameters. Now I'll say this dot height equals, sorry, I got a constructor has a name. This dot height equals 0.0. This dot width equals 0.0. This dot depth equals 0.0. And this dot weight equals 0.0. Those are all default values that I'm putting inside my default constructor. Boom. All right. All right, next. And also one more thing, string manufacturer and string name. So it has a manufacturer and a name. This dot manufacturer equals empty string. This dot name equals empty string. All right, default constructor, I have a class here. I could create an object. So I could say something like this, device D equals new device. Right, that works now. I can create an object. I can create a device object. Cool. But I don't want to do that right now. So inside my device class, I want to provide an overloaded constructor where a user can pass in all this information at the time of creation. Public device string manufacturer string name and double height, double width, double length or depth, and double weight. Right? And then this dot manufacturer equals manufacturer. So whatever is passed in, this dot name equals name, whatever is passed in. This dot height equals height. This dot width, width. This dot depth, depth. And this dot weight equals weight. All right, so now I have an overloaded constructor where I can pass in all this information when I create my device. For example, if we go back, I have this right here. This calls my default constructor. However, I can also do this, device d overload equals new device. I can pass in the manufacturer, so Samsung, the name, Galaxy, the length, I have no idea, but I'm gonna say 6.6 in inches. The width, I don't know, 3.5. Sorry, those should be doubles, 6.6, 3.5. the depth 0.25, and then the weight, I'm gonna say 1.5 pounds. Right? So the reason I did that overloaded constructor was so that I can do this now. When I create my object, I can pass in all of this information at the time of instantiation, right? And that's why I did that overloaded constructor. This one up here calls my default constructor with no parameters. This one right here calls my overloaded constructor with parameters. Everybody with me so far? If I asked you if you're with me so far, whatever, you can just give me the thumbs up. I think there's that little symbol in Zoom. All right, cool. All right. All right, so now I've done all this. The next thing, and the first thing of the first pillar that we learned was encapsulation. Encapsulation specifies that we must make every variable in a class private. So private string manufacturer, private, everything private, private. Private. Cool. All right, so now we have all of these private private things. And actually, I'm going to change name to, I'm just going to get rid of name. Actually, I'm going to change it to model. Yeah, model. Manufacturer and model. There we go. And then right here, I need to change this as well. All right, so encapsulation tells us that we must make every variable private and then provide getters and setters in our class in order to access those. So I'm going to type the first two, public string get manufacturer, and I'm going to return this dot manufacturer. The next one is the setter, public void set manufacturer string manufacturer. And I'm going to set this dot manufacturer equal to whatever we passed in right here. And we would do this for every variable right that we have up here set as private. You would type it out. NetBeans has this nice little feature, refactor, encapsulate fields. You select all, hit refactor. And now we have all of our getters and setters. All right, I don't know why I put it above everything. So let me move this. I don't want it up here. I want it down here. All right, so now you see we have all of our getters and setters, which means this class is now fully encapsulated. And we fully encapsulated. We have our private variables and our getters and setters. So now instead of this, I can do d.setManufacturer.model set, and I can pass in Samsung. I can also do d.setModel, and I can pass in Galaxy. d.set height 6.6, yada yada yada. Now I have setters in order to set all these different variables. I don't have to do it in my constructor anymore. I can get rid of this now, if need be, right? Depending on your use case. So cool. That was encapsulation. Everybody good with encapsulation? Again, thumbs up would be nice. All right. That's encapsulation. Let's move on to inheritance. So we have our device. So So let me create a new class, Java class. I'm going to call this smartphone. I have a smartphone class. Smartphones have string owner. They have an owner. They have a string phone number, right? They also have a string carrier. Carrier could be another object, depending on how deep you want to make this. And they have string, let's see, what else does a phone have? I don't know. Let's just stick with this, owner, phone number, and carrier. So let's provide public smartphone. We're going to do our default constructor. This.owner equals empty string. This.phone number equals empty string. This.carrier equals empty string. First, I want to call super. That calls my super constructor as well. All right. Then I want to provide another constructor, public smartphone, that passes in all this information, owner, string, phone number, and string carrier. Cool. And then we're going to say this.owner equals owner, this.phone number equals phone number, this.carrier equals carrier. All right. Next, I want to encapsulate this class. So we're going to make all of these private, 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 and private. Now I'm going to say refactor, encapsulate fields, select all, refactor. And here we go. We have all of our getters and setters. So next, I want smartphone to inherit from device because a smartphone is a type of device. So simply to do that, we would just say extends device. Our smartphone inherits from device. It extends device. So if we look back at our device, here is our constructor. I'm going to copy this stuff, put it right here, so that now I can do this right here. I can call my overloaded constructor super, pass in manufacturer, model, height, width, depth, and weight. I call my superclass constructor, which takes me over here, and I pass in all of this information from my subclass. All right. The next device I want to do is a camera. New class camera. All right. Camera has private double megapixels. Let's see, what else does the camera have? I'm just going to stick with megapixels. All right, because device already has the manufacturer and model. So we want a constructor, public camera, this dot megapixels equals 0.0. Then I want to encapsulate the field, refactor, encapsulate fields, select all, refactor, and I want to extend device. Right? Camera is a type of device. Cool. Now we have two different types of device. We have a camera and a smartphone. Well, if you think about it, we can have cameras, and then we could have, you know, digital cameras. We could have the little old printing cameras that print as you snap pictures. But smartphones also have a camera as well. So what I can do is private camera. I can have a camera object in my smartphone. Refactor, encapsulate fields. Refactor. Get camera and set camera objects. All right, this smartphone has camera objects built in. And so I would say the last thing to pass into this constructor is a camera object, camera. Then I would set this.camera equals new camera. Over here, I would just say, not new camera. This.camera equals the camera that we pass in. Up here, I would say this.camera equals new camera. All right. So now we have our smartphone. Our smartphones have an owner, a phone number, a carrier, and a camera. And that camera is an object of our camera class. But note, both your smartphone and your camera are both types of devices. So they have a manufacturer, a model, a height, width, depth, and weight. All right. The next thing that we have is polymorphism. All right, polymorphism. So polymorphism specifies that we can create a device D, right? Device D, then system.out.println, what type of device would you like to create? System.out.println, 0 smartphone, system.out.println, 1 laptop. I'm sorry, not laptop, camera. And then depending on what they say, so int choice equals scanner or input.nextInt, which means I need a scanner object. Scanner input equals new scanner. System.in. I want to read in from the console, import scanner. Read in whatever choice the user selects, switch on that choice. If they enter in a 0, I want to say D equals new smartphone. Right. Although device D is a device, right, the superclass, because smartphone inherits from device and thus contains all of the characteristics of a device, I can set D equal to a new smartphone. Break. Case 1, D equals new camera. Same thing for camera. Since D is a device and both smartphone and camera inherit from device, I can set D equal to a new smartphone or a new camera. Okay. And then let me create a method, public static void create device. Device D. I want to pass a device into this method. And you see, this expects just a generic device. So I can do this, create device, and I can pass in D from up here, I think. Yeah, okay, so I need a default case because D equals new device. Because there is the possibility that the user doesn't type in a 0 or 1, and therefore no device would be created, and that was the issue. So I just set D equal to a new device. Right? And then I pass it to this method, and I can actually do it this way. So I can get rid of that default. I'll do it up here. So I call in create device, and this method, it expects a generic device, but again, since smartphone and camera both inherit from device, I can do this. Then of course in here I can put in the code to populate the devices. And I can say if the instance of, it's all lowercase, smartphone, meaning is D, whatever device that we passed in, is it an instance of a smartphone? If it is, populate a smartphone. I can also check else if D instance of camera, populate a camera, right? I can check what type of device this is, smartphone, camera. If I had other ones like laptop, desktop, TV, I can check instance of laptop, instance of TV. That instance of is key, especially as we do inheritance and polymorphism, right? Polymorphism specifies that we can use dynamic binding, which basically dynamic binding means that we create a superclass and at runtime we decide what type of object it'll be. So do we decide, is it going to be a smartphone? Will it be a camera? That's dynamic binding. Polymorphism also allows us to pass in a superclass or a subclass into a superclass and then check what type it is, right? So we can do all that stuff with polymorphism. So we've covered encapsulation, inheritance, and polymorphism. Everybody with me so far? Right. The last thing to cover is abstraction, which for this example, in the real world, we don't have just generic devices. I don't even know what that would be, right? Any device that we have is typically something else. So for example, headphones are a type of device, but they're headphones, right? A speaker is a type of device, but it's a speaker. So you typically would never have just a generic device. That doesn't really exist in real life. So if that's the case, we can make device abstract. Yeah, we want other classes to inherit device, but we're never going to create a device object. Like a user isn't going to create, you know, device generic equals new device. You typically wouldn't do this, right? I mean, users wouldn't have no generic device because it means nothing. What type of device it is? I don't know. It's just a device. No, that doesn't make sense. But we want other classes to inherit from device, right? They are types of devices. So we have smartphones, we have cameras, we have speakers, we have TVs, we have laptops, desktops, whatever it may be. All of those are types of devices, right? But we don't have just generic devices. So we make device abstract because we know it exists. It's a concept, but it's not a physical manifestation. There is no physical manifestation of just a generic device. It's more of a concept. It's abstract, right? And so we would create an abstract device class for other classes to inherit from. Like a smartphone is a type of device. Camera is a type of device, right? We want them to inherit all those characteristics of whatever we think of an abstract generic device is. So that's abstraction, right? We make an abstract class because we want other things to inherit from it, but we don't necessarily want to create objects of it, right? We don't want to create just a generic device. That doesn't make sense. So we make it abstract so that other classes, smartphones, cameras, speakers, headphones, all of those can inherit from it as well. Cool on abstraction. Again, those are the 4 pillars. And if you don't get anything else from this class, learn those 4 pillars. encapsulation, inheritance, polymorphism, and abstraction. Those are the 4 main concepts in this class. This class is all about object-oriented programming, and those are the foundation of object-oriented programming. If you know those 4 concepts and you know them well, you can pretty much transfer to any coding language out there because it's pretty much the same concepts. It has those 4 pillars, but the syntax may be different. So how do you declare a variable may be different. But underlying it all, same foundation. Any questions?
No, sir.
All right.
No, sir.
If there are no other questions, that's it for today. Of course, I'll see you on Friday face-to-face in the classroom. And it'll be a lab on try and catches, I believe.
All right, have a good one.
You too.
Good day.
You too.
Have a good day.
Likewise.